Hello, everyone. Not big of a crowd at the moment, but hopefully people will join in later on. So my name is Mario. My colleague Mladen is here in the first row. He'll jump in the second part of the presentation. Today we are here to present to you Husky, a Combis big data solution. So basically today I will give you initially at the start, I will give you a business overview of how we see Husky and where we see the opportunities to go ahead with this big data solution. And then later on, Mladen will join in and go more into technology and the demo of the system itself. So basically a few general information about Combis. It was founded in 1990. Since 2010, it's a member of Deutsche Telekom Group when it was purchased by Croatian Telecom. Based on several different market associations, Combis is one of the leaders in Adriatic region when it comes to IT services provider. Combis at the moment has over 400 employees, and the revenue for the 2014 was over 70 million euros. This is a list of references. As you can see, we are regionally present in different sectors. So from telco industry to banking sector, insurance and finance, retailers, FMCG, and other similar companies, transport and logistics. We basically want to diversify our portfolio as much as possible in order to keep up going forward, actually. Now, considering you're part of DT Group from 2010, I would say it was logical for us to go ahead with the customer needs in terms of telco industry. Basically, for big data purposes, of course, monetization of available data is one of the most important things, and definitely one of the things that customer in terms of telco would need to accept and achieve. So we see two streams for achieving monetization of big data, basically. First one is definitely cost savings. So to reduce costs by enabling better decision making. Basically, if you have big data solutions such as Husky, it enables you to make better decisions in a smaller amount of time, enabling you to allocate your resources to maybe some other open projects and issues, enabling you to utilize your time, virtually your money on a better way. The second stream would definitely be additional revenue. So basically, telco operators can use big data to improve its own decision making and its own business processes, but also telco operators have the opportunity to basically sell data and analytics on the market to its business customers. We see similar things happening in Croatia as well, and that's the aim that we're heading to. Regarding the description offering itself, for telco operator, obviously, they will have a quick data integration, enablement, anonymization, and processing of that data, which, as said already, enables them to make decisions much faster, and those decisions will be based on the facts that can be measurable, actually, so they will have something to lean on when defending those decisions. That's from the telco perspective. On the perspective of a business client, they will have relevant and up-to-date customer information, which always comes in handy for each business, so from banks to insurance agencies and similar business clients. Also, they will have a targeted customer approach, meaning that if data is provided to them on the right time at the right place, then they will be able to offer its own end users and its own clients services and offers which in any other case would not be able to offer to them. So that's something that they didn't have up to now. Of course, business clients also want comfortable point-and-click tool. Mladen will show you more on that part. Basically, Husky key points from telco perspective are definitely the fact that data itself is telco proprietary. So one big problem, if you want to call it the problem, with big data and big data solutions is that you need to have data. If you don't have it, you need to buy it. If you need to buy it, then it costs money, it takes time, and so on. In case of telco operators, they already have the data. They just need to collect it. They need to analyze it and process it, and then they need to provide certain analytical reports for their own purposes or to sell it on the market, basically. Second thing, which is quite important for telcos and any other business client for that matter, would definitely be real-time data. So basically, if you have real-time data and you can process it on time, it enables you to gain a lot of important things. For example, geolocation campaigns are always based on real-time data, because if you're on a particular location in a particular time, then you need to get a particular offer at that time. If you get it 2 days later, then it doesn't mean anything to you. A third point, standardized solution with possibilities of customization. So basically we have a solution which is standalone, and we can provide it with you. We can provide it to you. But the thing is, with big data, options are limitless. So basically, for any additional module or use case that any particular client could have or want to have developed, we can basically jump in, make it possible, convert it, and make it a part of the customized solution. Finally, simple usage. You will see during the demo presentation that basically you can get a hang of using the tool in, let's say, half an hour, maybe 1 hour max. So that's pretty much it when it comes to user friendliness of the tool. Of course, tool itself can be used as a cloud service, so no hardware or additional software licenses are required from your side, from the client's side, of course. Now, final slide for my side at the moment. Basically, here you can see Husky as a system. So this is the high-level architecture. You can see Husky as a big data platform, and you can see data sources that Husky can use. Of course, this is a telco operator case, so of course, data source, one of them definitely is mobile network. We also have a Wi-Fi network, data warehouses, CRM information, user registration questionnaire, third-party data, or GIS. So when I say third-party data and GIS, I mean Google Places, TripAdvisor, pretty much any other third party which has an API which can be connected to Husky, and then import that particular data that you might need. All of the data is then gathered into a trust center, which does a lot of things, but basically one of the most important of them is definitely anonymization. So basically when the information leaves trust center, the information itself is separated from the identity of each particular subscriber, end user, and any other private information. After leaving trust center, the information then and data go to particular module that actually client or subscriber wants. It can be enterprise reporting and heat maps module, geolocation campaigns module, smart internet lead enhancement module, or 3G, 4G smart rollout module. After the data is being processed in each particular module, then the final analytics are readable through web GUI, through Excel reports, or API, depending on customer needs. Okay, so Mladen will continue.
Okay, hello again. So what you see here is actually a simplification of the overview Mario gave earlier. In our case, we have the infrastructure layer, which consists of the mobile cell and base stations all around Croatia, which actually gather all the data about mobile device users, where and when they connected and what they did. Then we have the enablement layer, which is actually the trust center, which provides anonymization services and then serves as an interface or an API for other systems, other applications to connect and retrieve the data. And finally, we have the application layer where our Husky resides, and it's used for analysis, presentation, and finally, of course, monetization of this data. As far as technology goes, we have several different groups of technologies which are presented on the slide, but I'd just like to mainly focus on our big data stack, which consists of the following 4 technologies. The first is the Hadoop framework. Why is Hadoop important? Well, Hadoop is actually the one of the first and the leading MapReduce framework, and also the distributed file system, or the HDFS. For Husky, we use it only as a data store, so we use only the distributed file system part. Why? Well, because in the MapReduce engine, Hadoop's MapReduce engine, at least previously, saved all its intermediate data to disk, which was, of course, very slow. Instead, we use Spark, which is another MapReduce engine, but it does its MapReduce tasks in memory as much as it can, and therefore speeds up the entire process up to a factor of 100, if necessary. So we use Spark for data processing, and then the results of this data processing are stored in Elasticsearch. And one additional technology we use here also is the Kafka distributed queue. Why is it necessary? It's necessary if we want to use our application in online mode. So if we want to receive data in real time, then Kafka is the queue where data is stored, and then it's used as a source for other data processing tasks. In addition, I'd just like to mention Ansible, which is a great tool for managing all these machines, because every technology in the big data stack is distributed, so it can be run on multiple machines. So we use Ansible to orchestrate, that is, to manage all these different machines in a simplified and very easy manner. So these are just the highlights of what I described for the previous slide. Additionally, I'd just like to mention Spark Streaming, which is an addition to Spark used for online processing. Initially, Spark was designed only for batch processing. That is, you get a large amount of data, and then you run some job once, and then you get the results. But in real-time processing, things are a bit different, because you receive data in real time. So Spark Streaming comes in handy here, because it's a nice API actually to write all these MapReduce tasks in a real-time environment. For those of you who may have not seen this before, I'd just like to give a short example for what MapReduce actually is. Well, MapReduce is a programming model or a paradigm that actually enables us to run distributed data processing in a way that it's easily accessible. You can program in it easily and so on, and it takes care about distributing all the tasks among many machines. In this example you see here, suppose we have some large text file where we want to count words. Well, how would we do that in a MapReduce paradigm? Well, we would first divide this large text file into many smaller pieces, and then send each piece to a different machine to process, to count the words in it. And then after processing, which is the first stage, also called the map step, we would then gather all the data, all the results from the different machines in a reduce step and combine them to get the final result. So our pipeline concerning this MapReduce paradigm, these MapReduce steps are given in the slide, of course, only the simplified view. We have two types of processing, both batch and online. In the first pipeline, the input is the HDFS, so the distributed file system, where we store the data, the large amounts of data, and then use it as a data source for data processing, for batch processing in Spark. And then finally, we store the results in Elasticsearch. Whereas in real-time processing, we use Kafka as an input and also as a data source for Spark streaming. And the same as before, we store the results in Elasticsearch. So now finally, I would like to get to the point actually and to show you a brief demo of our application. Forgive me, some of the parts of the application are still in development, some more, some less, so if some quirks occur, I apologize in advance. So what you see here is, what you see here is the main console for Husky, where you can see 3 different use cases. The first one is network planning, the second is tourism analysis, and the third one is location scoring. So what exactly is network planning? Well, in this use case, the Croatian Telecom was actually interested in analyzing the usage of 4G network in the country and then finding out what are the most interesting areas for them to build and install new cells and base stations that support the 4G signals. For example, let's say you have some area which is not covered by the 4G signal, but you have many users with devices capable of using this signal. Of course, you will be interested in putting a cell or a base station there to profit out of it, because then these users will be able and would in the end use this 4G traffic. So we can select through a simple interface, we can select this view, which enables us to query the data we analyzed and use some parameters, specifically in this view, the CRM parameters. I'll just select the entire last year as a range for the data we want to examine. Specifically, this is our demo environment where we have about 10 or 12 days loaded. And when I click on search, the data is presented to me as a heat map, where the red parts are the parts where the Croatian Telecom users had the most activity, so where there were more of them and so on. While the green and the blue parts are those with less frequency. And I can see this actually quite fast in a near real time. I can examine the data for any part of the country. And then let's say I am a business user that's interested in, for example, finding out the location of, let's say, all the ladies between 20 to 29 years old. And then I would just select the parameters, and then the system would display these values and these results. And now I know, okay, here somewhere in Zagreb, near the center, near the main square, there was the most female activity. And I can also inspect this by hours, where I see that, for example, during the night, the frequency is much less, so there was practically no activity in the center of Zagreb, and there was more activity in the outskirts and so on. And how when I move through the different parts of the day, I can see this data changing. So I see that the people actually moved and started using their cell phones more and more. And using this data and also some other overlays, like, for example, the current coverage of the 4G signal, I can analyze. I can find, for example, the places where it would be okay to install maybe new 4G cells and base stations. And additionally, on top of this all, we are also trying to develop some new new additional tools and algorithms and so on. For example, let's say I'm looking at this area, I could cluster the results, that is, try to find out the hotspots the areas where there was the most activity, and then according to some parameters, the system isolates only those parts that had the high activity. So this was it for the first use case. The second use case is tourist travels, where we can analyze for various network users. We can see their nationality, and then we can see where they moved, which cities they visited, where they traveled, and so on. Here, I'd like just to show a simple use case that's quite relevant because of the recent events. For example, I will select the date, the 19th of September. And I would just like to select the nationality. Of course, this is concerning the recent migration crisis, where we can see that the people from, for example, Iraq, how they moved in Croatia. And you can see also that it corresponds to all the news we heard and so on about how they were transported. And the final use case I would like to show briefly is a use case useful for marketing purposes, which is location scoring, where we can select, for example, a single shopping center, and then for a specific day in a year, for example, the 21st of July, we can see some statistics about the visitors. So that is the shoppers, the people that actually went inside the shopping center and did something there, and the visitors, the people who were maybe on the parking lot and so on. And I can see the distribution by hours of shoppers, visitors, by gender. I can find out the peak values, so the hours of day when there was most activity and so on. Also distribution by years, where we can see different statistics, and we can see, for example, that mostly people from 20 to 29 years visited the center. And also I can see the distribution, the map distribution, where we can see the parts of the city and the country where people mostly came from and went to after visiting the shopping center. So we can see, of course, as in a heat map, the red and yellow values indicate stronger values, while the blue and green colors indicate weaker values. So this is, for example, the city center west. We can see that the dominant visitors were from this part of the city, from the west, of course. And then if I select a new test location, which is actually the arena center, I can see that all the statistics changed a bit. Why? Well, because it's in a different part of the city. So I can see, okay, many people who went to the shopping center were also in these parts of the city, and how they gradually distribute across all the other parts. And what's also interesting to see, for example, is, for example, here, since you have, there is a cinema in the arena center, you can see that this drop of shoppers, of people who entered actually the shopping center, is still strong, but not as strong in the evening, because some people remained in the cinema. Then, for example, for the city center west, where it declined sharply and dropped practically to zero. So these were some of the main use cases. Of course, there are many more. There is practically no limit. The only thing you need is imagination to pull out whatever kind of information you want from specific data. And that's it for our part. If you have any questions now, I'll be pleased to answer them. Yes?
Okay, first question is what kind of databases, Husky is capable to collect the data from? And second question is, does Husky support encryption?
Well, for your first question, Husky currently does not collect the data from the databases, but the data we analyze is provided to us in practically large text files. So these are actually logs from the various cells and base stations, but it is possible in the future, of course, to integrate with different kinds of databases. But for now, we didn't have it planned. As for your second question, no, we currently do not have any encryptions. Can you be, for example, maybe more specific as to what you had in mind?
Yes, since as I saw, some kind of data could be critical for security or such things. I mean, for the customer would like maybe to encrypt such data. If you collect such data and store it somewhere, customers are rather to be encrypted.
Okay, well, so actually some kind of encryption is not needed on that level. Why? Because the laws in Croatia actually require us to first anonymize the data, which is what the Trust Center does. So we do not know exactly which user went to, I don't know, a specific part of the map. We only know its randomly generated ID. So we don't know, for example, if I visit a shopping center right now, the system wouldn't see me as Mladen, but it would see me as some kind of a random number. So I cannot connect this data to a specific person. And secondly, also important, all the data we store is aggregated. So we do not know that person 1, 2, 3, 4, 5 was in city center west. But what we do know is that there were, for example, 100 people there, because we only know the aggregated data. So we know there were 100 people there, maybe 40 males, 60 females, or 40 males, 50 females, and 10 unknown. So we don't have the data and so on. So the data is aggregated, and the data is previously, during analysis, the data is also anonymized. So we cannot pinpoint to a specific user. So in that sense, there is no actual need for this encryption you mentioned, at least to mine. Okay.
Is there any option or perhaps a plan to support some kind of modeling future events? For instance, so you can pick a random week in the future and check what the tool predicts that the, I don't know, number of users in a city center will be, what is the day of the week when some part of the city will be the most visited or something like that. So basically analysis of the last data and some kind of a future prediction.
Yes, you mean like projection of the data?
Yeah.
Well, currently, no. Currently, we only can examine statistically the past events. But it's, of course, also an interesting addition to the existing use case. And it's something we'd like to very much do, because we're actually interested and we have the capabilities, we have the platform. Now all that is left to do is actually to come up with such kinds of ideas and then implement them. Of course, the algorithms are maybe a bit tricky, not everything is as straightforward, but of course it's an interesting idea we would maybe like to develop in some time.
Thank you.
Thank you.
Any more questions? No? Okay, thank you.
Okay, thank you.